right, these are our notes, our first notes for chapter 5, which is about proportionality. So proportionality has a lot to do with unit rate. So you learned unit rate last year in math, and then you did that review for me the other day, and we're going to apply that into making what we call a direct proportion equation. And then next year we're going to take that equation and you're going to plot lines on a coordinate plane. So see, everything just kind of keeps on building on each other. So we're taking that concept of unit rate and applying it to proportional relationships. So first of all, we have to decide if things are proportional or non-proportional. And in order to do that, it says if the ratios or rates of two quantities are, I should say, equal, then the quantities are proportional. It means it's going up at the same pace every time. If the ratios or rates of two quantities are not equal, then those quantities are what we call non-proportional. So here's an example. Jasmine is baking cookies and mini cupcakes for a competition. The tables below show the number of cups of sugar she has used for each dessert after every 3 dozen made. Complete each table and determine the type of relationship. So to determine if something is proportional or not, whenever we're looking at a table, we do what we call y over x. Okay, that means we take the y and we divide it by the x. So the first list of numbers is always the x, and the second list of numbers is always our y. So I'm going to put x right here to remind myself and y over here. Okay, same thing over here. This dozen is going to be represented by x, and then these cups of sugar numbers, that's our y. So the first thing we have to do is take our calculator and do a bunch of division. And it's always our y number divided by our x number. So some of these are definitely easy enough to do in our heads. Other ones we might want to use our calculator for. So 12 divided by 3, y divided by x. 12 divided by 3 is 4. So then I'm going to do it again. 22 divided by 6. Oh, I don't know that one off the top of my head, so I'm going to use my calculator. And I find out it's 3.6 repeating. Okay, 36 divided by 9. 36 divided by 9. Oh, I can do that off the top of my head. That's 4. 45 divided by 12. I'm not so sure about that one, so I'm going to use my calculator. Y divided by x. 45 divided by 12 is 3.75. Okay, so now let's do it for the mini cupcakes. Same thing. Y divided by x. So 9 divided by 3 is 3. 18 divided by 6 is 3. 27 divided by 9, I can do that. That's 3. Y divided by x. 36 divided by 12, that's also 3. So I'm going to look at the sugar in the cookies used first. So this graph first. And I would say the sugar used in the cookies is not equal, or we can use the word non-proportional. Probably should have used that one instead. To the number of dozen baked because, well, why is it considered non-proportional? Because the rate is not the same for all batches. This rate would need to say the same thing for all of them in order for it to be proportional. So this is a non-proportional rate relationship because the rate is not consistent. It changes over time. Okay, but then if I look at the sugar in the mini cupcakes, here's my rate that I came up with. My y divided by my x always gave me 3. So I would say the sugar used in the mini cupcakes is proportional to the number of dozen baked because the rate is always the same. Okay, so to decide if something is proportional or not, I find the rate. If it's the same all the way down, I say the same all the way down, I say it's proportional. If it's not the same, I say it's non-proportional. So let's practice a few of these. Determine whether the quantities in each table represent a proportional relationship. If yes, give the constant rate. Okay, so the constant rate, we call that the K. I don't know why K, so don't ask me. I'm not quite sure. But we call it the K. And the K is just like what we were talking about before. It's the Y divided by the X. This right here is called the constant of proportionality. The K, it's called the constant of proportionality. And again, we find that by doing Y divided by K. And if it's the same all the way through, we can say it's proportional, and the constant of proportionality is the K, the Y divided by X, that unit rate. Okay, so let's try this. Here's a table that goes like this. So the top one's always the X, the bottom one's the Y. So I need to do Y divided by X. I'm just going to write my number right in here. I'm going to squeeze it in. So I'm going to say 30 divided by 5, that's 6. 60 divided by 10, that's also 6. Now, I know part of you want to go, oh, I'm done. There's 2 6s. Always check all of them, because sometimes there's trick ones where they'll be the same and then all of a sudden the last one is different. So always check every single value that's given to you. All right, 90 divided by 15. Yep, that's also 6. And 120 divided by 20. If I don't know that, I use my calculator, but that's also 6. So I can say that this is proportional. So I'm going to say yes. And then it says, if yes, give the constant rate. So let's get used to writing K equals, okay, our constant of proportionality, our Y divided by our X is 6. So I'm going to say K equals 6. Okay, let's try it again. This time we're comparing hours of snowfall to the total accumulation. So after 1 hour, there was 3.5 inches. So I'm going to say 3.5. Okay, now I'm going to do, remember, this is my X and this is my Y. So my Y divided by my X, 6 divided by 2 is 3. So really, I could stop right now because I know this answer is going to be no, but I want you to continue filling out the chart. So after 3 hours, there was 8.5 inches. So I'm going to do 8.5 divided by 3, and I get 2.83 repeating. And then after 4 hours, there was 12 inches, and 12 divided by 4 is 3. So I would say because these numbers are not all the same, no, this does not represent a proportional relationship. Super simple concept. Okay, find the unit rate. If they're all the same, it's proportional, and that unit rate is what we call the constant of proportionality. If they're different, then we say they're not proportional, and there is no constant of proportionality, so we wouldn't even answer that question. Okay, I'm doing one example of completing tables. I wish I had room on here for more, but there's also stuff we have to do on the back. So I'm just going to show you one. I think you're going to catch on really quick, but it says if the following tables represent a proportional relationship. So I'm telling you it's a proportional relationship. Complete the table. Lucy spends $1.75 on a cup of coffee each day. So here's the number of days she buys her cups of coffee. We're going to figure out the total amount she spent. So what the number that's given to you, that's going to be your constant of proportionality, because I told you right here, this table represents a proportional relationship. So I'm going to say, okay, $1.75 per cup of coffee. So 1 cup of coffee would cost $1.75, or 1 day, $1.75. If she buys a cup of coffee each day for 3 days, how much is it going to cost? So I'm going to say, oh, my unit rate, or my constant of proportionality, is $1.75 times 3 days this time. And I find out she spends $5.25. So I just have to take that $1.25 $1.75 and multiply it by 3. So here I did $1.75 times 1. Here I did $1.75 times 3. Now I'm going to do $1.75 times 5. If she buys that coffee every day for 5 days, how much is she going to spend in total? She's going to spend $8.75. And then I do it one more time. $1.75 times 7. If she bought that cup of coffee every day for 7 days, I find out that she spends $12.25 a week on coffee. So that's how a table would work. If you're given the constant of proportionality, we just plug it in the other number and multiply them together. All right, let's do the back side. So I kind of already talked about it, but we're going to mention it again. So what is the constant of proportionality and how do I find it? So again, from the front page, the constant of proportionality is a fancy term for unit rate. It really isn't anything different than the unit rate. We find the constant of proportionality, k, by dividing y over x. We already talked about that. X, or k, equals y over x. Now, something new that we didn't talk about on the front is called a direct proportion equation. And we write a direct proportion equation by saying y equals kx. That's always our direct proportion equation. Y equals kx. And what that's saying is when I find the unit rate, all I have to do is multiply it by the x, and it will give me the y. Kind of like what we were doing on this table down here. We knew the k was $1.75. We were multiplying it by the x, in this case, the days that she bought coffee, and we would come up with the y. That's what this equation is telling us. Okay, remember, I could also work backwards, which we're not going to do right now, but we will eventually. I could give you the y, and I could give you the k, and you could find the x. That would work also. So here we go. For these examples, it says, for the tables, determine if y is directly proportional to x. And then if it is, we have to answer the other two questions. If we circle non-proportional, we can't even do anything else and we're done. So it's kind of taking what we did on the front and just applying it to that direct proportion equation that's right here. Okay, so I even put the x and y's on here for you. The table below shows the cost, y dollars, for x pounds of strawberries. Okay, so here's my y, here's my x. I'm going to do 2 divided by 1. I get 2. 4 divided by 2. 2. Remember, go all the way across. 6 divided by 3. 2. All right, great. They're all 2s. So because they're all 2s, I know it's a proportional relationship. What's my constant of proportionality? Remember, that's my k, and that would be my unit rate. All that unit rates that I found over here, all my y divided by x's. So I would say k equals 2. And then my direct proportion equation, I just use this, but I fill in that number in the k slot. So I would say y equals 2k, or sorry, my bad, 2x. I replace the k with my constant of proportionality. So let's try it again. The table shows the distance traveled by a school bus, y miles, after x hours. So here's my table. I'm going to do my y divided by x. So 100 divided by 2, that's 50. 150 divided by 3, that's 50. 200 divided by 4, that's also 50. So proportional or non-proportional, since my rate is constantly the same, I'm going to say it's proportional. My constant of proportionality, that's my unit rate. So I would say k equals 50. And then I plug that into my equation. So I would say y equals 50x. So that means I could plug any number in for x, and you should be able to tell me the y. Okay, last one. The table shows the number of pitches made, y, in x innings of a baseball game. So after 1 inning, 15 pitches, 2 innings, 30 pitches, 3 innings, 50 pitches. So let's find our constant of proportionality first. Let's find our unit rate. Okay, so y divided by x, that's easy. 15 divided by 1 is 15. Okay, so after 2 innings, it was 30 pitches. So 30 divided by 2, that's also 15. But remember, I always got to keep going. So after 3 innings, it was 50 pitches. I'm going to do 50 divided by 3. When I do that, I get 16.6 repeating. And see, this is why it's important to go all the way out, because it started the same and then it changed. So because my rates are not all the same, I would say this is a non-proportional relationship, and then that's it. I can't do the rest of this because I circled non-proportional. All right, that is it. If you have questions, we can kind of talk real quick tomorrow before the STAR test, and that's it.